Alright, so we'll now look at differentiating in terms of x. So we have quite a number here. So we have questions involving the product rule, we have questions involving the logarithms, questions involving the quotient rule, logarithms, product, chain rule, logarithm, product rule. So we'll solve them. So question 1, as you can see, it's a product. So we have x squared multiplied by x to the power 3 plus x to the power 4. So this is a product of two functions. Okay? So let's call the first function to be x squared, and then the other one to be v to be called let's have the other side x to the power 3, right? So we'll call it, our v will be called x to the power 3 plus x to the power 4, right? So now we have to differentiate all these. So u prime is going to be 2x, then on the other side v prime is going to be 4 x to the power 3 plus x. The power has to reduce by a 1, right? We are applying the chain rule to differentiate v. So when the power reduces by 1, it becomes 3. Don't forget you're supposed to multiply by the derivative of what is in the brackets. So that is 3x squared plus 1. Okay. So due to lack of enough space, so let me move it a bit. So that's what we have. So we have applied the chain rule to differentiate v. So a basic idea of a basic argument of the product rule is it doesn't matter what you start with. So I'll start with x squared, and then I'll multiply by the derivative of the other part, which is that. So that is 4, open brackets. So I'll start with the first part, x to the power 3 plus x to the power 3 multiplied by 3x squared plus 1. And then plus, we can now go to the second part, which is x to the power 3 plus x to the power 4 multiplied by the derivative of the very first part, which is 2x. This is what the product rule tells us to do. Now at this point, 4 times that is going to be 4x squared. I can start with that part if I want to, or instead I can factorize. I can see this is common. So what's the highest common? Or maybe if we are going to do that anyway, if we're going to do that, it means let's first of all multiply. So we have 4x squared, and then we remain with x to the power 3 plus x to the power 3, and then we have 3x squared plus 1 in brackets. Now the other part, we will have 2x and then x to the power 3 plus x raised to the power 4. So this is where we've ended, and if you want, you can take an extra step by simplifying the solution by factorizing. You can see x is common. Let me just say 2x is common, right? So you can have 2x. So the very first part, what remains is what? If we pull out the 2x, we remain with a 2x. And then what else can we pull out? Now we can pull out this part. We can see this is common, this is common. So the highest common power is 3. So I have x to the power 3 plus x to the power 3. Now in the brackets, what remains? When we remove 2x from 4x squared, we're going to remain with 2x, and then we're also going to remain with 3x squared plus 1 for the first part, plus the other part, 2x is already pulled out, and then we'll remain with a single power since 3 has already been pulled. So x to the power 3 plus x. So of course you know what is in the brackets can be simplified, right? So I have 2x, x to the power 3 plus x to the power 3 in brackets. So 2x times that is going to be 6x to the power 3 plus 2x plus x to the power 3 plus x. That's what we have there, right? So now at this point, we know the like terms, right? So the like terms are 6x and that. So we are going to have 2x and then x to the power 3 plus x to the power 3 in brackets. So you remain with 7x to the power 3 plus 3x. So you can end here, but you could have ended even just before this. There's no harm. The basic idea is they want to see if you understand what method you're going to use to simplify any given question. So the next one is involving now the natural log. Natural log of 1 minus x squared, 1 plus x squared. So I want you to pay particular attention to what we can do here. So whenever you've got a natural log or any log, they say, the formula is very, very simple. Okay? So whenever you've got a natural log of u, what's the derivative? Derivative is going to be u prime over u. That's all. Very, very simple and straightforward, right? So what that means is, if you're going to have a natural log of x squared, the derivative of x squared is 2x, the derivative, and then you maintain whatever is attached to the natural log x squared. So this gives you 2 over x. That's how you differentiate the natural log. So you can do the same. You can literally do the same here. How? First of all, differentiate this using the quotient rule. Put your answer on top and then divide by itself the way it is. That's one way of handling it, right? Simple and straightforward. Now I don't want to use this method. I want to apply a bit of some logarithms. So logarithms tells us when you've combined the log of two different things that you're dividing, it implied that we were sharing what? The log, sharing the base. So I can expand this using logarithms. This is natural log of 1 minus x squared. Now when you're subtracting, it implies, or when you're dividing, it implies you were subtracting. So minus the natural log of 1 plus x squared. So these are just logs. Now at this point, this is going to be easier. Now what's the derivative of what is in the brackets? It's negative 2x. We'll maintain whatever is in the brackets. The other part as well, the derivative of that is going to be 2x. We'll maintain what's in the brackets, 1 plus x squared. So this is simple and straightforward, right? Than going by the quotient rule, which you can also easily do. Okay. Now, of course, if you want, you can simplify this beyond this point. Come up with a common denominator. If you want to find the same answer that you find, if you go the other way. So you want to simplify this, right? So 1 minus x squared plus 1 plus x squared, because that's a common denominator. Okay. So after I divide by that, what remains is the other part. So it's negative 2x multiplied by 1 plus x squared, and then minus, and then you have 2x on top multiplying by 1 minus x squared. At this point, what we have, so negative 2x multiplied by that to be negative 2x minus negative 2x to the power 3. This part, negative 2x plus 2x to the power 3 over. So if you check what we're multiplying on the denominator, it's more like a conjugate, because the sign is just changing. So it will just be 1 times 1, and then negative x squared times negative x squared will be negative x to the power 4. If you want, you can go step by step. You still end up with the same result. So let's see what's subtracting here. So this part and that part are of opposite signs. So on top we remain with negative 4x over 1 minus x to the power 4. Okay, so that's where you end for part 2. Alright, so question 3 is very simple. Just apply the quotient rule. So feel free to pause the video and try it out. So we have 1 plus x to the power 3 divided by x squared, right? So we have got two different functions dividing, so we'll use the quotient rule. Quotient rule tells us if you're going to have u over v, the formula that you can use is v and then u prime minus u v prime over v squared. Okay, so if we're going to let our u be what is on top, we can go on and substitute in the function or in the equation there. So what is our v? Our v is the denominator, x squared. Now what is u prime? U prime implies you differentiate whatever is on top, right? Because our u is equal to that. So our u is equal to 1 plus x to the power 3. What's the derivative there? So the square root is the same as what? The square root is the same as raising something to the power half. So if we're going to differentiate it, it's going to be half 1 plus x to the power 3, reduce the power by 1, it will be negative half, multiply by the derivative of what is in the brackets. That's going to be 3x squared, right? So at that point, what we're going to have after simplifying this, 3x squared over the 2 after multiply by the half and that, and then in the brackets we're going to remain with 1 plus x to the power 3 raised to the power negative half. We know we can take that to a denominator so that you can have a positive power, right? So we can have 1 plus x to the power 3 raised to the power half. Now positive half is the same as the square root. So therefore, our derivative becomes 3x squared over 2 root of 1 plus x to the power 3. Okay, we can continue in the formula. So minus u, so our u is our numerator, so that is root of 1 plus x to the power 3 multiplied by v prime. V prime is the derivative of what is on the bottom, which is going to just be 2x, right? Over, now well, the denominator is going to be v squared, so that will be x squared squared. I think at this point all we are remaining with is just now the idea of us simplifying whatever we have. Can we simplify it beyond this point? That's the question. So this times that is going to be 3x to the power 4, and then over 2 root of 1 plus x to the power 3, right? And then minus the other part. What are we remaining with? So we're remaining with if you multiply this times that, you're going to have negative 2x and then square root of 1 plus x to the power 3, of course, over what's on the denominator, which is x squared squared, which is going to be x to the power 4. So at this point, dividing by that is as good as multiplying the entire thing by 1 over x to the power 4. So if you multiply the first part by that, you notice that they will divide, right? So you essentially remain with what? You're going to remain with a 3 on top, and then 2 root of 1 plus x to the power 3, and then of course this times that, you remain with only a 2, so minus 2 root of 1 plus x to the power 3, and then on the bottom we have x to the power 3. So basically at this point you are done with the third one. Okay, so let's continue with the fourth one now. So here we have the natural log of 2 plus cosine of x over 3 minus sine of x. So how do we basically get to differentiate this? How do we go about it when it comes to differentiation? So all the same, I would advise you pause the video and try it out. So initially I said you're supposed to expand this, right? When you're dividing, it means if you separate them with the same base of the log, you're going to subtract. So this is natural log of 2 plus cosine of x, and then minus natural log 3 minus sine of x. Okay, so at this point we understand that for natural log, I said whatever is attached, the derivative of it over the original is the derivative. So what's the derivative of 2 plus cosine of x? So you know that the derivative of a constant is a 0. Now derivative of cosine is negative sine. Okay, derivative of sine is cosine. Okay, take note of that. So derivative of cosine is going to be negative sine over the original, which is 2 plus cosine of x, and then minus, for the other part, what's the derivative of 3 minus sine of x? The constant will cancel out. Derivative of negative sine, sine maintains the sign, so if it's a negative sine, it will be negative cosine. So negative cosine of x over the original, right? Which is just 3 minus sine of x. So at this point we have negative sine of x plus cosine of x Okay, this is over 2 plus cosine of x, and then that is 3 minus sine of x. I think this is okay to end at this point. Very, very fine. Okay. So you clearly show that you understand how to go about the logs. You clearly understand how to basically differentiate them. You can go by the other method and see, which will require you to first of all use the quotient rule, determine the derivative what is in the brackets, and then divide by the same one, 2 plus cosine of x over 3 minus sine of x. So try this one out and see if you're going to end up with the same result. And if not, it means you can basically go on and simplify this beyond this point, which is not necessary. The next one is product rule. So pause the video and try it out. So I've already explained how you basically differentiate an exponential. So how do you differentiate an exponential? An exponential differentiated by multiplying by the derivative of the power. So what's the derivative of negative 3x? That's a negative 3. So therefore, if you multiply by negative 3, what you have is a derivative. Okay? So therefore, if we're going to set it out, it will be x squared. U prime is 2x. Our v is e to the power negative 3x. Therefore, v prime becomes negative 3. So notice that for an exponential, the power doesn't change. So therefore, y prime, it doesn't matter what you start with, but you need to multiply these. So if I start with x squared, I'm supposed to multiply by the derivative of the other part, which is negative 3, e to the power negative 3x, and then plus. So the other part, e to the power negative 3x multiplied by 2x. So at this point, what's common? Anyway, you can factorize for yourself. So I'll leave it at this point. When you multiply this times that, it will be negative 3x squared e to the power negative 3x. And then the other part will be plus 2x e to the power negative 3x. Now at this point, this is where you can now see what is common, right? You can see that e is common. You can also see that x is common. So you can have x and e being common. And in the brackets, what remains for the very first part, you have negative 3 and an x remaining. Then the other part, you just have a 2 remaining. So that's what you have. That's what you have after differentiating that. Now when you check the next one basically involves just the chain rule. Y is equal to cosine x to the power 3 minus 4. How do you go about it? So our y prime is going to be, ask yourself, what's the derivative of cosine? What's the derivative of cosine? So we say derivative of sine is cosine. Derivative of cosine is negative sine. Just this will help you. So the derivative of cosine is negative sine. So you have negative sine x to the power 3 minus 4. Now don't forget that you're supposed to multiply by the derivative of what is in the brackets. Derivative of what is in the brackets is 3x squared. The constant minus 4 just disappear. So what you end up with will be negative 3x squared and then sine x to the power 3 minus 4. So what is your derivative there? Alright, so we'll do a second from last question, where y is equal to the natural log of ex squared. Let me write that properly. So we've already looked at the question that relates to this, so pause the video and try this one out. So e to the power x squared over e, that's not e, that's x squared. Okay. So I've already shown you the ways to go about it by expanding the logs, but let me show you the other alternative way now of going about it. So what you'd want to do is, first of all, determine the u prime of whatever is in the brackets. What we have in this case, we have e to the power x squared, and then over x squared. So we are supposed to apply the quotient rule here. So the quotient rule, remember, your formula is, if you're going to have u over v, our formula is going to be v u prime minus u v prime, right, over v squared. So our v is what's on the bottom. So we have x squared. Now u prime, which is the derivative of whatever is on top, you say it multiplied by the derivative of the power. Derivative of x squared is 2x. So I have 2x attached to the exponential. The exponential, the power doesn't change. And then minus u. U is e to the power x squared. And then v prime. V prime, the derivative of x squared is 2x. Divided by v squared, which is x to the power 4. Right. Okay. So that's where we are at this point. Can we simplify beyond that point? So if you multiply this and that, you're going to have, that's going to be 2x to the power 3 e to the power x squared as it is, minus 2x e to the power x squared as it is, over x to the power 4. Now don't forget that at that point you're supposed to divide by the original as it is in the brackets. So that is e to the power x squared over x squared. Now I've already shown you that dividing by something is as good as multiplying by the reciprocal, right? So if we're saying we're dividing by e to the power x squared over x squared, it's as good as multiplying by the reciprocal, meaning that you change, you swap them. So it's the same as we're multiplying by x squared over e to the power x squared. Okay, so let's move to the next step. So if you do that, if you do just that, let's see what you're going to have. So take this to be individual terms, this and that to be individual terms. Okay, so x squared times whatever is on top, we're going to have 2x to the power, that will be to the power 5 now, that will be x to the power 3, and then over x to the power 4 will be attached by ex squared. So you notice that ex squared is now common everywhere, right? It's attached at every point. So you can actually factorize it on top. So if you do pull it out, e to the power x squared, it is going to divide with 1 on the bottom. So what remains as your solution is 2x to the power 5 minus 2x to the power 3 over x to the power 4. Of course you can go on and simplify that. You know that since you've got x to the power 5, 3 and 4, the minimum power is 3, so you can pull out x to the power 3 on top, remain with 2x squared minus 2 over x to the power 4, which can be split. So this and that will go. So you end up with 2x squared over x as a simplified solution. Okay. Now for the last one, we apply the chain rule. Okay. So when you see y is equal to cosine squared and then x to the power 3 minus 4, the meaning there is it's like what you have is cosine and then x to the power 3 minus 4, and then all this is raised to the power 2. That's what it means. Okay, so cosine squared of x is not equal to cosine x squared. These are two different things. Okay, this means cosine of x raised to the power 2. That's what it means. With that understanding, we'll let our u be equal to whatever is in the bracket, so that we have y is equal to u to the power 2. Now we know that our u is equal to cosine x to the power 3 minus 4. So we can basically determine du there So our du dx, what's the derivative of cosine? Negative sign. So multiply by the derivative, what is in the brackets, that's going to be 3x squared. Okay, if you simplify that, you're going to have negative 3x squared sine x to the power 3 minus 4. Differentiate this in respect to u. It's going to be called dy du, which will be 2u. Now for us to get du dx, dy dx, it's a product of dy du multiplied by du dx. So dy du is 2u, and then our du dx is this part. So negative 3x squared sine x to the power 3 minus 4. Now our u is basically whatever was in the brackets, right? So we said cosine of, so that would be 2 cosine x to the power 3 minus 4. Now we are multiplying by negative 3. Negative 3x squared sine x to the power 3 minus 4. So this time that we're going to get negative 6x squared, and then sine x to the power 3 minus 4 cosine x to the power 3 minus 4. So what is basically our derivative by applying the chain rule there? If you think you can simplify it to further than this, please feel free to go on. Right.